Welcome, everyone. Today, we are going to be talking about writing readable code. So primarily today's discussion is going to be about making our code readable. What is readable code? Why do we need it? What are some of the benefits of it? And essentially, how do we write it? So we're going to focus primarily on these two core topics today, but we're going to be covering it from multiple different angles. So primarily, we're going to be looking at what is readable code and how do we write it. So let's begin with what readable code is. So readable code is simply code that literally communicates its intent to the reader. So basically, it means that when you pull up some code or any type of software, be it HTML, Java, C, .NET, whatever, that you look at the code and you understand what the code is doing. What is the functionality of the code? So what are some of the benefits to using readable code? Why do we want to focus on readable code? Well, one, it makes it easier for us to understand what the code is. So any developer can come in, open up the code, and look at the code and understand what's going on. It's very clean, easy to read. We can understand how the code works. So if the code is written cleanly, it's documented well, I'll be able, for instance, someone could come behind you. They could easily make a code modification. They could fix a problem that's been reported by a customer, or they can understand how quickly it is or where to add a new feature or functionality to an application. And interestingly enough, having readable code also makes it easier for us to write testable code, like unit testing, JUnit, PHP, whatever. Because if the code is written cleanly, if we have defined our functions, methods, whatever in a clean way, we should be able to identify how to test them. It makes it very easy for us to work through this. Some of the other benefits of writing readable code is it also takes those software documentations, requirement documentations, and we can then take that piece of documentation and actually put it in the code where it belongs. So we know that this code goes with this functionality or this requirement. Alternatively, if we don't write readable code, it's hard to understand. It's very hard to read. It's not very understandable by other developers. It's very hard to understand how the code works. Typically, when we don't write readable code, you'll hear developers say, oh, the code's unmaintainable. It's spaghetti code. We don't know what's going on. Those are signs that your code is not readable. It was not written well. It's also very hard to make code modifications, fix a problem, because the code is unreadable. It's unmanageable. You don't know what's going on. You don't know where to begin. And you also don't know where to add new features, because if you don't know what's going on with the code and you can't read it, you're kind of stuck. You don't know what's going on. And then the same thing applies to testing. If the code is unreadable, you don't know where to test. You don't know how to test. You don't know where to test different features in the software. So how do we write readable code? Well, there's essentially 4 ways you can write readable code, but really I've written 5 here because it all begins with documentation. You have to have some clear type of documentations, either requirement specification document, some type of test plan, some type of business requirements. You have to have some documentation around the software that you're going to be writing or that you're going to be updating. So documentation is a real key feature here. However, so many companies and so many organizations skip this step for very small module pieces of requirements in smaller tickets. They give you smaller chunks. And we don't have that large document giving us a big overview of how our software works. So documentation is key. The other thing for documentation to think about is you're actually writing a message to your future self with this documentation, or a future developer. So documentation is basically going to be telling the next person or a reminder to yourself in the future as to what this code is for. What are we trying to do with this piece of software? The other thing with documentation that is interestingly enough is if you write clear, concise documentation about how an application works, the different requirements, this also can become a good marketing strategy for your sales department to go out and actually sell the application, to actually explain it to customers when they're presenting it or doing demos on the software. This is also a good area, good piece of documentation or a good document to have to basically flush out a lot of the problems that your application could potentially have or bugs or features that were missed in the initial design process. So that's where we start, is with documentation. Now, this documentation can then be broken down and moved into the code in different places. But before we get to that, let's talk about the next step. So the next feature or the next piece that you need to write readable code is coding standards. These basically define how it is that we are going to write our code. What are the different requirements we need based on our language, based on our environment, based on our architecture that we should follow so that every time we bring in a new developer, they are going to know how to write the code, what to expect when they're looking at the code, and everyone is basically following the same template as they're writing their code. If you don't follow a coding standard, basically anyone that comes into the organization or anyone that touches your code is potentially following their own rules, their own guidelines, and it can be a hot mess. The code could look very different from one class to another, from one function to another function, and really having standards really structures your code and makes it clean, makes it readable, and everyone can understand what's going on. Which kind of leads into the style guides. So style guides are the way you should organize your code, the way you should name your variables, the way you should name your methods, classes. All your languages have basic coding standards and basic style guides. These are going to be ways that you name your application files. Like in Java, you name your classes, the way you name your methods or your functions, the way you name your CSS files, what type of, do you use CSS files versus inline styles? So there's different ways of coding and different styles for different languages. So creating a style guide or following a style guide also helps improve the overall structure of readable code. Now, I've added this fourth one here, and this one can kind of be debatable, but another way to help your code be readable is to implement the practice of code reviews. Regardless if it's a SQL script, if it's a JavaScript file, Java file, .NET file, regardless of the language or what it is, any time you write or make a change to an application, it makes sense to do a code review. Code reviews help in a couple of different ways. One, it helps maintain readability, because if someone else reviews it and they can't understand it or they can't read it or they can't follow it, then it probably needs to go back and be refactored and cleaned up so that it can be understandable. Two, this helps flush out any potential logical problems or potential bugs that could be introduced into an application. Something that maybe the tester forgot to, or the developer forgot to test. They didn't think about a particular edge case. These are things that you can look at with or catch within code reviews. And code reviews are also a good place to help ensure that you're following those coding standards and style guides. And then lastly, practice. This is not something that can be easily done overnight. It takes a lot of time and a lot of practice to really get good at writing readable code. Typically, a lot of students coming out of college follow basically the examples and derivatives that they were taught in school. They will have one mindset of their coding standards or styles based on whoever taught them. So say you bring 5 students into one organization from different colleges, every single one may have their own styling technique. So in order for everyone to get on the same page, they need to start learning the coding standards. They need to learn the style guides. And the only way to really learn this and implement this is to practice, to do it, then to follow up with code reviews, and then make sure that the code reviews, that the code meets with the style guides, the coding standards, and back up to the documentation. So it's kind of a top-down approach or bottom-up approach, depending upon the direction that you're coming at this. So that's it for the slides. Let's actually jump out today and walk through a code example. It's a real simple example, but it really drives home what readable code is and how to make it work. All right. So first and foremost, I'm using Java, but you can use any language, PHP, Java, JavaScript, .NET, whatever. These principles I'll be talking about today pretty much apply to any language. So it's kind of language agnostic. So what I have here is I have this project example I created called documentation example. Now, this project in Java has to start lowercase. This is a standard naming convention in Java. This is a basic Java project with a basic structure. So the first thing I did was I just created a class called example1. Now, in Java, this isn't really the best practice. There's some additional features or some additional coding standards that you should really implement. And that's things like packages, where you do com dot the reverse URL of your site. Now, C# kind of follows the same practices, PHP, JavaScript, those can be slightly different as well. But really, depending upon the language, you're going to have some actual structure that goes around your application. And that kind of gets more into the coding styles and those. So that gets more into those coding styles and those style guides that we were talking about. But I'm not going to focus so much on that today, but I'm going to walk through some ideas on how to implement that physically in the code. So today we're going to focus just on the code itself. So I have this Java class here called example1. It's in the package document example, and it looks like this. We have some methods. Looks like we have 4 methods here. We have some main method, which will be where the application in Java starts. We have some code in here, but really it's not clean. Really, just by looking at this, we don't know how this works. So if we actually just come up here and try to run this, we get a result of 2.0. Well, that really doesn't tell us anything. So let me actually just run it as a straight Java application. Sorry. So let me run it as configuration. So let me just run this as is, no arguments. So if we just try to run this program, it fails. It says, hey, exception in thread main, Java array index out of bounds, index 0 out of bounds. Well, if you are not a Java developer, you're going to be like, what the hell does this mean? What's this exception? If you are a Java developer, this should actually have been handled. So this is a bug that potentially we need to fix. So to start with, we need to then kind of reverse engineer this code or walk through the code and try to understand what's going on. Well, the first thing we look at, though, is the code is gobbledygook. It's a big mess. And if you're dealing with JavaScript, there's a lot of times where you have to minimize your JavaScript. So all your JavaScript's on one line. So it's very hard to read. So you essentially need to drop your code into some type of IDE or formatter and actually let some tool either apply a code style for you, or you can apply your own coding format or coding style as you want. Since we're using Eclipse, we can kind of cheat and jump into the default parameters for whatever Eclipse is set up with. So here, if I do Control-Shift-F or Command-Shift-F, it's going to reformat our code with all the correct tabs, all the correct spaces, the correct line breaks, so that we can actually read the code, so that the code is now in a cleaner format. So first, we look at this. This is not real clean, not real readable. Yes, we can kind of see everything on the screen, but we don't know what's going on. It's a hot mess. So we first format it. There we go. All right, let me save those changes. So the first thing we did was we formatted. So now we can see, okay, we have 3 methods, method 1, 2, 3, and 4. We have our static main method for Java, which runs the application. And that's all we have for methods. Now, since I'm using Eclipse, I can also open up the Explorer here, and this gives me a nice outline view of the program. So we see, okay, we've got main, and we've got 4 methods here that take 2 parameters each of float, and they return a float value. So if we look at it a little bit more, we see, okay, method 1 looks like we're adding 2 float values together, returning the sum. Method 2, we received 2 values, we're subtracting. Okay, so we got a minus. Don't really know why it's just called method 2. Method 3, we're dividing 2 float values. Method 4, we're multiplying. So that's what those methods are. So right off the bat, we can see that, okay, this makes no sense. I really don't understand what's going on, but I have to go in to determine what these methods are doing.